Hi everyone, welcome you all. In this video, I am going to explain transfer function of SISO system, that is single input, single output system. Or I go to the agenda. Number 1, transfer function definition and explanation. Second, types of transfer function. Third, procedure to obtain transfer function. And fourth, characteristic equation of the transfer function. And 5, poles and zeros of the transfer function. And 6, advantages and disadvantages of the transfer function. First of all, I am going to explain the definition of the transfer function and then I'll give the explanation of the transfer function. What is the definition of the transfer function? The transfer function is defined as the Laplace transform of the output to the Laplace transform of the input with all initial conditions are considered as zero. Consider a block diagram of open loop system. In an open loop system, R of S is the Laplace transformation of the input and C of S is the Laplace transformation of the output and G of S is the transfer function. How to write the transfer function? G of S is equal to Laplace transformation of the output to the Laplace transformation of the input. That is known as transfer function. So L of C of t divided by L of R of t. Here the time domain is converted into frequency domain. Next I'll explain the transfer function. Explanation. Consider a linear system having input R of t and C of t is the output of the system. The input-output relationship can be described by the following nth order differential equation. Here this is the output C of t and this is the input R of t and where a, b are constants. Take the different Laplace transformation of the equation. So an s power n into C of s plus a n minus 1 s power n minus 1 into C of s plus a1 into s plus a0 into C of s. Okay, C of s is taken into outside. So inside we are having this term. And in a similar manner, Laplace transformation of the right hand side of the equation is bm s power m plus b m minus 1 into s power m1 m minus 1 plus b1 into s plus b0 into r of s. Okay, we can define the transfer function as g of s is equal to c of s divided by r of s. What is C of S divided by R of S? That is equal to Bm S power m plus Bm minus 1 S power m minus 1 plus B1 S plus B0 the whole divided by an S power n plus an minus 1 S power n minus 1 plus a1 S plus a0. So what is G of S finally? C of S divided by R of S. So these are the explanation of transfer function. We are going to see what are the types of transfer function. There are three different types of transfer function are there. First one is strictly proper and second one is proper transfer function and third one is improper transfer function. What is strictly proper transfer function? Denominator polynomial order is greater than the order of the numerator polynomial. We can say that the function is a strictly proper transfer function. And what is proper transfer function? If the order of both polynomials are same, then the transfer function is said to be proper. And what is improper transfer function? If the order of numerator polynomial is more than the denominator polynomial, then the transfer function is improper. These are the classification of transfer function. Next, we are going to see procedure to obtain transfer function. What are the steps needed? The first one is write the differential equation for the given system. It is a mathematical system, this is a physical system, mechanical system, that is rotational, pneumatic system, or hydraulic system. If any other system it may be, but all the system you have to write the differential equation, that is very must. Next, step number 2, take the Laplace transformation of the equation. Then step number 3, take the ratio of transformed output to input. The ratio of transformed output to input is the transfer function. So these are the steps needed to find out the transfer function. I am going to explain characteristic equation of the transfer function. The characteristic equation of linear system is obtained by equating the denominator polynomial of the transfer function is 0. So this is the denominator polynomial an s power n plus a power an minus 1 into s power n minus 1 plus a1 s plus a naught, that is equal to 0. Next, I am going to explain poles and zeros of the transfer function. So consider the following equation. The numerator and denominator is factored m and n terms respectively. Then the equation can be expressed as. Already in the previous slide I explained what is g of s. G of s is c of s divided by r of s. So already have got the answer bm s per m up to b naught. An s power n up to a naught. Now I have to factorize the denominator and numerator in terms of m and n. So g of s is equal to c of s by r of s equal to k into s plus z1 into ks plus z2 into s plus z3 and so on, divided by s plus p1, s plus p2 into s plus p3 and so on. From this equation, how we can find out poles and zeros? So first of all, you have to see how to find out poles. The poles of g of s is obtained by substituting denominator equal to 0 or g of s is tends to infinity. So s plus p1 into s plus p2 into s plus p3 equal to 0. So the poles are s is equal to minus p1, s is equal to minus p2 and s is equal to minus p3. And next find out zeros. The zeros of g of s is obtained by substituting numerator equal to 0 or g of s tends to 0, numerator equal to 0. What are the poles? S plus Z1, S plus Z2 into S plus Z3 equal to 0. The zeros are not the poles. The zeros are S is equal to minus Z1, S is equal to minus Z2 and S is equal to minus Z3. Next, I am going to explain poles and zeros of the transfer function for the example problem. So consider the transfer function g of s is equal to 50 into s plus 3 divided by s into s plus 2 into s plus 4 the whole square. So first of all, the numerator equal to 0, we get zeros. The denominator equal to 0, we get poles. So first I have to substitute the denominator equal to 0. So what are the poles? S is equal to 0, S plus 2 equal to 0, that is S is equal to minus 2. So only one pole, simple pole. And then S plus 4 equal to 0, minus 4, pole of order 2. And next zeros, S is equal to minus 3. Next, locate the poles and zeros in the S-plane. So first of all, I have to locate the 0, that is a pole, and minus 2 also a pole. Minus 4 is a pole, but it's a double pole. Minus 4, 2 poles are available. So I have to mark like this. And 0 is marked by means of one circle. So these are the way of plotting the zeros and poles for any transfer function. Next, I am going to explain the advantages of the transfer function. Transfer function is a mathematical model of all system components and hence the overall system, and therefore it gives the gain of the system. Since Laplace transformation is used, it converts time domain equation into simple algebraic equation. By the transfer function of poles and zeros, the characteristic equation can be determined. It helps the study of stability of the system. If the transfer function is known, output response of any type of input can be determined easily. We are going to see the disadvantage. Transfer function cannot be defined for nonlinear system. Transfer function is defined only for linear system. From the transfer function, physical structure of the system cannot be determined. Initial conditions lose their importance because we didn't consider the initial condition. Okay, thank you. Thanks for watching. Have a nice day.